So today we're going to discuss basics of transformers, what they are, what they do, and what they're made of. And then we're also going to test it, do a quick continuity test, and also megger the transformer to see if it tests out good. So we're going to start by just going over what this transformer is. We got a 5 kVA transformer that is 480 volts on the primary, and it steps down to 120, 240. There's a number of different types of transformers. There's step down transformers and step up transformers. What they do is they take one voltage and either step it up to a larger voltage, or they take the voltage and they step it down to a smaller voltage. Okay, so we're gonna open this up and take a look at the transformer, and I can tell you what transformers are made of. So just using a simple drill here with a number 3 Robertson bit. It all depends on what transformer you're working on. Some of them have hex head bolts. This one just has Robertson screws holding the plates in place here. So inside the transformer, the first thing you're going to see is the coils. So this is a single phase transformer, so there's usually only 2 coils that you're going to see in here. This one here has your high side, which is your primary, where your 480 volts will go, H1 and H2. And then this is the low side, where you get your 120 volts and 240 volts. And this one, the diagram shows me that you have 240 across X3 and X2, and 240 across X1 and X4. And then this is a delta connected transformer on the primary to Y connected on the secondary. So we have a Y connection that comes out of the windings, and which is your neutral in this case. And that's just down at the bottom here. With transformers, there's single phase transformers, there's 3-phase transformers, there's dry type, there's oil filled, there's a lot of different types of transformers. This one in this case is just the single phase, so it has the 2 windings. Most 3 phases, not all, but most will have 3 windings. And but in this case, this is just a single phase, so you just have the 2 windings here. So you don't need 3 phases of the 3-phase voltage to come on your primary. You just need 2 legs and onto the delta here, high side. So I'll open this up so we can take a better look, get these covers off. It's just a nice way to look inside without just having the front view here. So I took the covers off just so we can have a better look at a transformer and what it's made of. When you're testing a transformer, you don't necessarily have to take all the covers off like that. Some transformers won't let you take all the covers off. Most of them come on a simple base like this, and then they have the covers around them just so it's easy. If there is ever something that goes wrong with your transformer, it's easy to take it out and have it serviced or rewound. So now that we have the transformer opened up, we can have a better look of what a transformer is made of. This one particular here is just the 2 coils. So what we have here is an iron core, and you can see it here. This is your iron core. It's connected together. It goes through both separate windings on this transformer. And so the way the electricity travels is through electromagnetic induction, and that's how a transformer works. You put the electricity on the high side, 480 volt, and it travels through these coils around the iron core and produces, the way that these windings are wound, produces the low voltage 120, 240. Another little tidbit of information with the transformer, they come with the ratios. So this particular transformer, 480 to 120, 240, would give you a basic ratio of 4 to 1, just 480 divided by 120. And then also on the 240 side, 400 divided by 240, which is a 2 to 1 ratio. You can get into with the 3-phase ones. You have, for example, 600 to 120 would be a 5 to 1 ratio, and then the 600 to the 208 would be 2.88 to 1 ratio. So that's just, that gives you an idea. It's the amount of windings that are around the iron core, and just kind of a basic understanding of how that works. Okay, so next we're gonna test the transformer and make sure that everything's good and it's ready to go into service. So I'm gonna do a quick continuity test on the windings, and then the high voltage winding to ground, the low voltage winding to ground. And the continuity test is just for checking for opens in your windings. And then we'll do a megger test after, which it tests the insulation of the windings. So, and the continuity test is just simply done with your multimeter. You just turn it to the ohm reader. So on this transformer, because the high voltage winding, it's connected together, you should have continuity through the high voltage winding. So we'll do that first, H1 to H2, and it's ringing through. And then we'll check that the high voltage winding to ground, or the Y connection, there's no continuity. And it's checking through as well. So I'll do the H1 and H2, and that's good. And next we'll check the secondary windings. So I'll go X1 to X4. We got continuity. And then I'll go X3 to X2. Okay, and then I'll check each winding to ground, and there should be no continuity. Okay, so next we're gonna megger the transformer, and I'm gonna do this by meggering from the high voltage winding to the low voltage winding, and then high voltage winding to ground, and low voltage winding to ground. And so we have an old wound type megger here. So when you're meggering a piece of equipment, you're testing the insulation. What you want to look for on your meter is, as you're meggering this piece of equipment, you want to see the ohmic value increase. That's when you know that it's a good piece of equipment. If it decreases as you're meggering it, that means that you have a short somewhere in the winding, or if you're doing a piece of cable, there might be a short in the cable somewhere. So just gonna take my 2 leads here, hook one up to H1 and then one to one of the low voltage windings. And we don't need to megger each individual winding here, or individual termination point, because we already know that there's continuity between our low side and continuity through our high side, so they're connected electrically. So doing this will tell us if the insulation ratings on this is good. I mean, you can test each one just to be safe. It's not going to hurt anything, but for this purpose, we'll just do the high voltage to the low voltage winding here, or primary winding to secondary winding. So I'm just simply watching on the megger, making sure that it's increasing, and it is, so that's a good sign. And then I'll let it wind down a bit here. You can also use a digital megger that has a ground connection, so that you don't have to wait for this to dissipate, but there is a little bit of energy that will be stored in this. So next I'm going to do the high voltage to ground. Yeah, that's good there. And then I'll do low voltage to ground. That's good there. Okay, so now that we've tested the transformer, we know that it's a good transformer and this is something that we can sell. We'll list it on our website. There you can find, we have dry type transformers, oil filled transformers, high voltage transformers, pad mount transformers, and this is something that Savannah Equipment actually sells a lot of. The reason being, transformers are a piece of equipment that has no moving parts, and most of the time these pieces of equipment are protected with either a breaker or fusible disconnects. So if there is a piece of equipment that fails, that usually doesn't get back to the transformer, so that's a reason why they don't become ruined. Okay, that concludes our video today on transformers, the basics of transformers and the basics of testing transformers, what they are, what they do. If you liked our video, you can give us a like and a share on Facebook or subscribe to our YouTube channel. If you're interested in any used equipment, new or used, electrical, you can find us on www.savannahEquipment.com, or you can email us at sales@savannahEquipment.com. And look forward to our next video with Marty the miner over here. He's always looking for new and used equipment for us to sell. And thanks a lot for watching, and be safe out there, electricians.